Hello and thanks for watching Gary Teaches Maths. I'm continuing to go through the edXL higher tier paper from 2019, and this is paper 2. And I've got a question which involves a graph which describes the motion of a car moving from rest. This is here, the graph gives information about the speed v meters per second of the car t seconds after it starts to move. And so we've got a velocity or speed time graph, so speed on this axis and time on this axis. And what it's asking us to do is calculate an estimate of the gradient of the graph at t equals 15. So what we need to do is look for time equals 15, which is there, go up to the graph at this point, and then we're going to try and draw a tangent at that point. So I'm doing my best attempt at a tangent here. So that means a line which is just going to touch the graph at one point and actually has the same slope as it where it touches. So we've done that. You're allowed a little bit of leeway in this, so it doesn't have to be exact, but you've got to try and draw it with a ruler as best as you can. And then what we're going to do is we're going to draw a triangle underneath that to try and work out the gradient of it. So to do that, I'm going to pick two nice points. I'm going to pick this point here, and I'm going to draw it to there, and I'm going to pick another point there, so where it's at least on some of the main darker lines there. So now what I need to do is work out the distances. So for the x distance here, we can see that each one of these smaller squares is actually equal to 1 second. Sorry, two of these smaller squares is equal to 1 second. So we've got 5, 10, and then we've got 11, 12, 13, 13.5. I'm going to say 13.5 seconds. Again, obviously, because you've drawn this by eye, you might get a different answer to what I've got. So that's 13.5. I'm going to work out this distance now, the vertical distance between there. So that's at 10. There's 20. So it's 10 from there to there. And then we've got another 1, 2, and I'm going to say 3. So that's going to be 13 in that direction. So we can call this one delta y. So that means the change in y. I can call this one delta x. And that means the change in the x value, so the horizontal one. And the gradient is actually given by delta y divided by delta x. So if we take them two values that we've got 13 divided by 13.5. So I'm just going to work that out on the calculator. So we've got 13 divided by 13.5, and what we get is 0.96. So using my values, 0.96, and that would be meters per second squared. We've got seconds on that one, got meters per second on this one. So we've got to describe what our answer actually means. Well, actually, I've done that in some respects by calling it meters per second squared. If we find the gradient of the graph on a speed time graph, we actually get the acceleration. So the answer is it's the acceleration, but it's the acceleration at 15 seconds. So at t equals 15 seconds. So that's always the case. If we've got a speed time graph, then the slope of the graph at any point actually gives the acceleration at that point. So now what I'm going to do is attempt to do part B. So this is work out an estimate for the distance the car travels in the first 20 seconds of its journey. So what we need to know for that is distance, when we have a speed time graph, is actually the area under the graph. And what we can do is we can try and split this graph into equal strips in order to work that out. So we can see that if I take a point here, I'm going to split it every 10 seconds. So that's going to create 4 equal strips. So those strips are here, 1, 2, 3, and 4. And we're going to work it out by using something called the trapezium method. And what that is that we've split the graph up into a series of trapeziums, effectively, or approximating trapeziums. So here we go. This is, if I draw a straight line across the top of each one, what I get is a series of areas that are trapeziums. So we can see number 1 is a triangle, but we could consider that to be a trapezium where one of the sides is actually 0. So 2 is definitely a trapezium. So we can see for area 2, we've got this. This is area 2. And what makes it a trapezium is we've got 2 parallel sides. And the formula for the area of a trapezium is if this is H, and this one is A, and this one is B, then what the formula is that it's H over 2 times by A plus B. And what we're going to do is consider each one of these a trapezium and work out its area. So for area 1, we've got H is always the distance across the bottom, so it's going to be 10 for every single one of them. So it's going to be 10 divided by 2, and then we're just going to pick the 2 values there at one end. So that one is 0, and this height here we've got is 12, so plus 12. And we can work that out, and that will work out as 60 if we tap that into the calculator. So if we then do the next one, 2, so in this case we again have height, which is the horizontal distance. So it doesn't sound like a height, but we call it a height. That's the horizontal distance. And that's 10 over 2. And then we take the 2 values. So we take this value here. And so we're calling that one 12 plus this value, which is 20. And so if we work that one out, that comes out to be 160. We can then do part 3. Again, it's 10 over 2. And our 2 heights are 20 plus this height, which is, I'm going to say, is 18. If we read it across to this scale, it comes to here. Just draw a dotted line all the way across, at the risk of making my diagram even more cluttered. So that's 18 there. So 20 plus 18, and that works out to be 190 if I just tap that into the calculator. Then we do part 4, so the final area, and same method, that's 10 over 2 times by the 18, which is this height, plus this height. And for that one, I think that's bang in the middle there, so I think that's 12.5. So 12.5. Again, if I put that in the calculator, what I get is 152.5. And next thing we can do is the total area is just simply adding all these together. 1 plus 2 plus 3 plus 4. And if we do that, we actually get that it equals 562.5. And so as an estimate for the distance the car travels, then because we've been working in seconds and meters per second, then our distance is actually 562.5, and this is going to be meters because we've got meters here, and because we're working in seconds and the other unit there is seconds. So it's worked out, and that's it. So I hope that's been helpful to you. If it has, please like our video and subscribe to our channel, which is Gary Teaches Maths. And for more help and tuition, visit our website, which is bestmathstutors.co.uk. Thanks for watching.